occipital bone again. So far we've looked at the coronal suture and the sagittal suture and the occipital condyles and the jugular foramen, which is this giant hole here. There's a good way to put it in there too. Like that. And then there is, of course, the foramen magnum and then the hypoglossal canal. What cranial nerve do you think will go through the hypoglossal canal? The hypoglossal. So this is going to be the hole closest to the foramen magnum, closer than any other hole. Why do you think it would be if you think about the cranial nerves and their numbering?
It's the lowest one first.
It is number 12. Hypoglossal is number 12, so it's the closest to the spinal cord exiting the brain. Now that's when I actually first put this through. If you look, it's actually it's a hole in the occipital condyle. So here's the occipital condyle. There. It's a nice round hole. It's nowhere near the size of the jugular foramen. And the skulls will have the whole hole. Because remember, most of these are models. And so if it's a plastic mold, then they don't always, make the hole go all the way through. So you might just see a place where a bunch of pencil marks have been.
It'll probably break if they did a hole, like make the thing break off.
Well, this one didn't. It's a more expensive, it's a better model to actually make the holes. More work. Okay? Then if you go to the, so I'm going right down the markings list. And then if you look at the temporal fossa is the next marking. Here. And then the external acoustic meatus here. If you call it the external auditory canal on the exam, that is totally fine with me. Either term, but be able to know that they both mean this hole. Okay, the mastoid process we've also already discussed. The stylomastoid foramen can only be seen from an inferior view. Do you see that? See, here's the external acoustic meatus. Here's the mastoid process. And if you slide down the mountain, ski down, right into the stylomastoid foramen. Okay, now we're going to look at a new bone, the sphenoid bone. It can be best seen in a superior view, like this, cranium removed, although I'm lifting it up a little from the bottom. If you use your imagination just a little bit, you can see sort of an outline of a butterfly. That's the sphenoid bone, the butterfly. That means that you can also see it from the outside just a tiny bit. This is going to depend on how good your model is. This is part of it right here. Oops, sorry, that's a lot of glare. And, yeah, let's see. So here's the frontal bone and then the sphenoid bone, a little bit of it right here. Here's the temporal bone behind it. You see on the other side, it's funny, on the other side they show you a little less of it. You can see it's just a little square right here. And then you can also see it inside the eyes. In the eye orbit, this is the frontal bone, this top part of the eye orbit. The bottom part of the eye orbit is the maxilla, which we haven't looked at yet. And then the sphenoid is the back portion of the eye orbit. Another way to find it is if you look straight in. I love this view of the skull because anybody that ever tries to draw like a skull and crossbones, a skull is not a skull without these scary holes in the back of the eye orbits. Those holes all have names, of course, right? So this hole right here, I got to tilt it for you a little bit. There. Okay, oh, perfect, perfect, perfect. You can see both of the holes right there. Okay, this one, oops, sorry, my hand's in the way. That is the superior orbital fissure. I wonder if you can see it. Yeah, it's really big. Maybe if we look at from the superior view, you can see it here too. You see that? So again, this is a pretty good angle right here. You can see it right there. It's called a fissure because it's a hole, but it's a slit-like hole. So it's superior because it's on top of the orbit. So superior orbital fissure because it's a slit-like opening. Now, what cranial nerves move your eyeball? Yep. Oculomotor, abducens, and trochlear. So oculomotor's number 3, trochlear number 4, abducens number 6. All 3 of those cranial nerves come in through the back of the eye and move your eyeball. So that's why they need that hole. Now, what cranial nerve helps you see, gives you vision? Okay, now tilt it. See the nice round hole? That is the optic canal. It's a nice round hole. Now look, you can also find it from a superior view. Right there. On both sides, of course. Look. Yep. My pointer got stuck. There. See that? What do you notice about the angle?
Goes to the left side.
Yeah, so this one would come out here, and what would you call this place where they cross? The optic chiasma. Right here, and then the nerve tracks will continue to the back lobe, right, to the occipital lobe for vision processing. Okay, so another interesting thing is, right here on that sphenoid bone, the butterfly-shaped bone that we've talked about, do you see there's like a divot right here? You can stick your finger down into it almost. It almost looks like a saddle, and that's why it's called the sella turcica, because it means Turk saddle, and the anatomists named this in Latin many, many years before the English saddle was invented, when the Turk saddle was the one that had the high pommel. So this is called the Turk saddle. What important gland sits in there? The pituitary gland. And this is why if you were to dissect a cadaver and take the brain right out of the skull, the pituitary gland would most likely pop off and stay right in there. So it's not visible on a brain.
What's the butterfly?
The butterfly is...
So it's everything around?
Yeah. And so what do you think is one of the primary symptoms if someone has a pituitary gland tumor? They get blurry vision. Yeah. In fact, if you see how the optic tracts travel back through the brain, blurry vision is a sign of many different tumors in the tumors in different places in the brain could press on that.
With the butterfly, how come on the outside of the skull you only see it in tiny little areas? Does that mean that there are 2 bones that are like pressed up against each other, like overlapping?
Oh, right. Yeah, the temporal bone right here
Yeah.
does have some parts of overlap, I believe, with
So
the
they're
sphenoid.
kind of like that.
Pressed together.
Okay.
Yeah,
So you can see more of it, a lot more of it from
the
than
inside.
from the outside.
Yeah,
Okay.
definitely more from the inside.
Are there other bones in the skull that are like that? That are like,
You know, that's definitely the ethmoid, which we haven't talked about
Okay.
yet. But yeah,
So when
That's a
you-
good question.
When you say you're doing a superior view, you're actually doing